come in. What did we do in the last class?
Presentation.
No, I mean before that. We did discuss about the group piles or single pile. Single pile, huh?
Single pile.
One single pile.
Yes.
We didn't do the design, so I will discuss about that. We did talk about the loading, right? Quickly remind you that we have, remember the piles capacities have two components. One is the skin friction of the shaft, and the other one is the base reaction. Well, in order to test the piles under compression, we might use a dead weight and apply the hydraulic jack continuously increases the actual load in the pile so that you can monitor the settlement force settlement relationship with the specific gauges as well as the load cell. However, if you're only interested in the shaft resistance of the pile, and you might use a sort of tensile system that you pull the pile upwards, you pull it up. And while you pull it up, you no longer have the base reaction, but what you have is the shaft resistance. Well, it is important for us to see how the load deformation stuff proceeds. Well, what do you understand from this graph? You first you have good stiffness, right? This is the settlement, and this is the loading on x-axis. With the increase in load, you have linear relationship with settlement. That behaves like elastic modulus behavior of any material that in elastic range. However, after one point, you start having more settlement in respect to increase in the force applied. Well, that's what we call yielding. Yielding of the material, yielding of the pile itself, shearing of the soil. I mean, all same thing goes plastic. This is a plastic behavior, non-reversible behavior. And we can simply set our limit from this graph as a result of application of pile test. What point would you suggest as the strength? What is the strength as a result of that? Is it here? Is it here? I mean this level? Let me mark these so that you can tell me where it is. So I'm going to name this as 1, this as 2, and this level of force as 3. Tell me, where is the strength as a result of this test? None. 1, 2, or 3? For the newcomers, you remember the pile test? We apply a test, imagine, and we monitor the force through the load cell and displacement through the gauge. Then we have force deformation relationship. As a result of the force deformation relationship, this is settlement, the deformation, and the x-axis is the load. Initially it behaves elastic and then it goes plastic. Considering all these levels, What point do you think I have crash on my computer? I think it's updating. Just 1 second, I think. How many are we in this class? What course is that? What about dynamics? Any one of you take dynamics? Okay, let me reshare the screen. Yes, as I said, 1, 2, and 3. Which one is the strength for that pile that you tested? Is it here, the strength, here, or this level of walls?
Third one.
1, 2, 3. Which number?
Third one.
Third one. What is that? If you identify it, I mean, name it. Say, this is the maximum. This is the peak. What is it? Peak what? Unit. I need the unit. That is the maximum force that the pile can take. Right? After that force, what happens? It continuously goes flat, shears. No more strength gain. So if you're interested in the strength, this is the parameter. However, the strength is not always the only condition we have. Remember, we have two conditional assessments. One is displacement, the other one is force or stress. Well, you might have huge stress capacity even after yields or shears, but if you don't satisfy the settlement condition, imagine that you reach this level of strength after your pile is being penetrated inside the soil. Imagine that it was like that, and now it's like this huge settlement. Not realistic. I mean, for your building, having that much settlement of your piles, having this much settlement after you reach this level of strength is useless. So, in that case, you consider the settlement and you say 2.5 centimeter, for example, 5 centimeter. If this is your limit, then your maximum strength can be only this much, not number 3. Okay, this is two conditional assessments, strength and the settlement simultaneously. If you satisfy that and if you don't satisfy that, it will break. Okay? This is the idea that I needed you to have an understanding about the compatibility. This is what we call compatibility. It has to be compatible in between these two. strength and the settlement are in parallel. The same thing also applies to shallow foundations. If you have a shallow foundation and imagine that you design it, we did an equation, I mean, we did solve shallow foundation, pad foundation. Imagine that your foundation has the B measure that is okay with the strength, but if you don't satisfy the settlement, you keep increasing so that the stress reduces too much until you achieve the foundation dimension of B. There's an example here. We have several layers of soil, and the total depth is 15 meters. What we have is the groundwater table there. I remember telling you, if you have a saturated sand, simply neglect the shaft resistance, right? The shaft resistance around the pipe. So it says, find the capacity of this pile if the diameter is 80 centimeter, bored pile, and with these soil properties. Well, I can also find these properties if I know the SPT, standard penetration test result, borehole log. I know the geology, and I can correlate from SPT to CU by using those available formulas. I know the unit weight. This is a saturated unit weight. Why I'm interested in the effective pressure on the right? Because sand's confinement characteristics, sand's shaft resistance calculation relies on effective pressure, effective horizontal pressure. So for all these three layers, we will calculate shaft resistance. No, is there any information given for the base? If it didn't specify a hard rock or bedrock for the base, we will utilize the same soil for the base as well. We have two components, remember, base and shaft. Shaft has three different soils. For each soil and each height, it will be calculated individually. Let's see. Let's have a look at the base. Well, based on what I said initially, if it's clay, I mean, if clay continues below the level of pile, it's called floating pile. This pile is basically floating inside the soil, right? It doesn't touch any hard soil. The suggestion of the design code says 9 Cu is the quantity that you are allowed to use for the base only, if clay. So 9 is the NC, Cu is the parameter that you have undrained conditions, resistance, shear resistance. It's given as 100 kPa. And the base area, the circular area. I know the diameter, pi d squared over 4. This is my base reaction. For my pile, I'm going to have base reaction, which we call it QB. And we have three more components. And let's name these as QS1 is the first, QS1, QS2, QS3. The very first one is in between 0 to 4 meters. Remember, it was clay. We know the strength. For clay, again, we will utilize alpha, Cu, and the shaft area. How do I calculate the shaft area? What is the area of that shaft? Tell me.
Pi r square over 4
Pi?
r square.
No. What is the... I'm not interested in this area. I'm interested in that area.
This is a laser.
Pi times diameter times L. 4. Pi diameter L. Imagine that you cut it and you open it. Now it's a rectangular form. Okay. We've calculated the area. We multiplied with the alpha coefficient. You remember alpha is the angle in between pile and the clay. Depending on the type of clay, the coefficient is suggested by 0.85. 60 is the Cu assigned for that specific soil. Easy for clay. Let's look at the quantity. Well, reasonable. Let's see the sandy soil. You remember for the sandy soil, we have the Ks coefficient. Ks over K naught was 1. So K naught and Ks are equal to each other. Tan delta is given as 0.75 phi dash, and phi dash is given as 30 degrees. We will utilize the internal friction angle, and we will calculate the tan delta. So this is basically delta, not phi. Yes, its delta is equal to 0.75. That's 22.5. Ks is taken from the chart. Remember, it's in between 0.5 and 1. You may select any property in between. The quantity is, the area with the same method. We have Ks1 here. The area here this time. What is the height of the corresponding length is 6 meters. Pi times diameter times 6 gives you the area of the shaft in the second layer of soil. Then we will simply utilize the difference in between effective vertical pressure, basically the trapezoidal stuff. Let me go back and draw it there. We have a quantity there, 72. We have a quantity there, that's 133. We will take average property of this, average of this value. How? By simply this plus that value plus that value, divide by 2, gives you the average vertical stress. Ks property was 0.5. Tan delta angle is calculated as a result of 0.75 times 30 times the area of the shaft, the second area. That is my component for the second layer of pipe. Calculated. But as I said, it's up to you as designer to neglect this component, right? You might not use it in your calculations if you don't trust the sand too much at that specific location. But if it's firm sand, I mean stiff sand, you might use it. And then we proceed to the last component that was very similar to the first layer of soil, 0.75 times 100 times the area of the shaft again. If you sum all these up, you end up 2,316 kilonewton for a single pile. But this single pile, in real life, you don't use it as alone. You use it as a group. You have many of them, closely spaced maybe. So you need to use factor of safety. It depends on how you utilize the factor of safety. If you utilize it separately for base and the shaft one by one, then you need to use 3 for the base as factor of safety, this one, and 1.5 for the shaft. This is the safe capacity of a single pile. Now we will proceed solving a group pile. But can you tell me why we have reduction in the group capacity when we have closely spaced piles? Any one of you want to discuss that? Why? And what was the quantity? 1,300. Why, when I have a single pile, my safe capacity is 1,300, and when I have them spaced closely to each other, why I have this capacity less than 1,300? Imagine that you have a thick rough foundation on top of it, solid, rigid slab, and it distributes equal. But still, your expected capacity from those piles, when are in group, is less. Why? It's just a simple logic. I mean, if you think a little bit.
Distribution is not affected.
Distribution is not affected, no. How are you going to construct this? You will excavate, right? During the excavation, what happens to the surrounding soil? You disturb the, imagine that you do this excavation, you disturb the soil here, right? While you do this, you disturb that region. So this intersection is no longer same strength that you had initially. But if you had a single pile, it would be. Okay? You disturb it. I mean, imagine this. You disturb that kind of, I mean, you're not going to excavate, but after you, this is what happens basically. After you excavate, this soil is being disturbed, maybe fall off, maybe shear, maybe it has tensile cracks inside, right? So imagine that. Okay, so having them close to each other is not the best idea. I mean, having them too close to each other. Anyway, the distance that you specify between the piles is from center to center. So if you have a huge diameter, right? This is, for example, 1.2 and 1.2 from center to center. Let's draw it here. We initially had, what is the diameter? 0.4. 0.4. 0.4. 1.2. So the actual distance in between is 0.8. Right? So imagine that you have a greater diameter, like the previous question. We had, let's say, 0.8 and 0.8. what would be? I mean, 0.6. It would be 0.4. Like, unrealistic, right? Very unrealistic to have that much spacing in between. Why we have group of piles? What is the main idea to have the group of piles? Why I don't have a single one in the middle? Why we need it?
Is this much more load?
Much more load. Okay, so how can I achieve bigger load with less piles? Huh? Length. Instead, you make them more, right? And short. Have this instead. In this one, because the distance is greater in between, the efficiency, right? I mean, the performance will behave better with the money you pay for the material. Because in the end, although you have more material here in the length, but the quantity will be less. It's not sure if it's, I mean, I cannot say for sure this is always the best option. Because it depends on soil. I mean, if the soil is weaker down there, imagine that you have a weak soil, going deep doesn't help anyway. But if you don't have weak soil and you have stronger soil back there, down there, this is more economical. So for each condition, it will be your midterm, not exam, but assignment. For each case, each condition, you need to try and see how the situation changes, right? And find the most optimum design, okay? Optimum means safe plus economic. If you don't satisfy that and just memorize, do it in one go, no, it's not a good design. Let's see this example of efficiency calculation. How are we going to calculate the efficiency of those piles? We have in total 12 piles in this example. The question says, find the allowable bearing capacity of a single pile and then find the total capacity of this raft with those piles. We will neglect the capacity of the raft foundation here. I mean, you have a contact with the soil there, but we will neglect it. And the reason for that is usually we construct those piles a bit higher in height, and this will be fill material. The contact in material, soil material, will be a fill material. That's why it will deflect and it will settle with the time, and you will have no contact with the raft and the soil underneath, okay? But because of the compatibility equations, remember from the strength of materials, this one, compatibility conditions, you will only have those piles resisting raft, not the soil underneath. Let's see, for a single pile, an easy attempt, it's 100% clay. So 9 Cu times AB will be my base capacity, and the shaft capacity will be alpha times Cu times the circumference times the length of the pile. This is defined as the length. Alpha is taken from the slide if you want to have a look at it. A single property or factor of safety is assigned in this question. It's given to you. And so the safe capacity is 275.8. Well, now we will discuss the pile group efficiency. This is a simple form of the formula, the efficiency. Efficiency is in between 0 to 1. If it's 1, it means 100% efficient. Whatever you calculated, I mean, you didn't have any reduction in efficiency as a group. But if it's, let's say, 0.5, it means whatever you do, only 50% will work. So 1 minus theta arctan d over s, d specifying the diameter, s is in between spacing of those piles, but from center to center, it includes d in the formula, and you basically calculate an angle as a result of that. M are number of rows, n are number of piles in a row. Let's go up. How many rows do you have? 1, 2, 3. How many piles do you have in each row? 1, 2, 3, 4. Basically, this kind of formula should remind you, I mean, talking about the soil mechanics. Does it really matter which one is number of rows or which one is piles in a row? Look, in terms of mathematical expression, it doesn't really matter which one is m and which one is n. These are interchangeable. So you simply put those in and you end up with 0.71. What does that mean? 71% efficient, right? How may I increase the efficiency? If I want to increase, I lost 29% of the piles. We will increase what? We will increase the size of the piles, you said?
Number of rows are the size of the pile.
I mean, it's wrong.
We will increase the number of piles.
Increasing the number of piles
Like one will get extra.
will reduce the efficiency. I'm interested in increasing the efficiency.
I want to increase the efficiency of the pile.
Yeah.
What if we increase the size of the pile?
Okay. We just discussed it. I mean, increasing the efficiency, you need to reduce the quantity of the piles. Having less piles, so the spacing will be larger. Larger the spacing you have, more the efficiency you have. Okay? So have them taller, deeper, but less in quantity. Okay, so what is the total capacity? Then you calculated a single pile in a group capacity, and this is a safe value, 195.8, simply times 12. This is another method by Terzaghi and Peck reduction method. And based on that method, is that some dash? I mean, okay, so Let's say we have another problem when we have the total building's weight. So I give you like your midterm question. You will design a foundation. You will design two types of foundation in your midterm project. One will be the shallow foundation. The other one will be the group pile. Let's say you know the building's weight. So you will design your piles. You will decide diameter, quantity, and the depth with the assigned soil profile. Let's solve one example on Excel so you see what I mean. And then I will finalize this after midterm examinations. This is the last lecture we talk about the design of piles and sort of, and then we will move to the seismic design and seismic analysis of the soil, and then we will also do stone column as alternative to this. The benefit of stone column when compared with the pile is that when you do the compaction of the stones inside the soil, you don't have reduction in the group efficiency, because you basically apply compaction sideways and then you don't have reduction because of the distortion of the soil. But that's a good benefit that we can utilize. Okay, let's say the building, the same plan. I will utilize the same example. And for the next lectures, I want your laptops to be here so that I can help you downloading some software. Okay, the question says, calculate if the capacity of the pile group is adequate. Or 5,000 kilonewton building weight.
The whole structure weight, like
Whole structure weight, that load, I just gave you a value. If not, redesign or optimum. Two questions you have. Let's see the first one, 5,000 kilonewton. We initially calculated the capacity. One single pile, efficient with the efficiency property, I mean the real expectancy of that pile is 196. How many of them we have? 12. Number of tiles. 12. Capacity. Efficiency. 0.71. We calculated, and capacity was initially. I put it that way because I will change now. 276. So pile group capacity plus that times that times that kilonewton. Is it adequate? Does it resist the applied load? No. Why? Plus 5,000 is smaller than this. You ask Excel and it tells you false. No, it's not. So what should you do? If I change the number of piles, I have to update this as well. Efficiency as well. Right? If I change the depth, I have to update the capacity of a single one. So we will input everything here and we will do it several times. I mean, deeper, closer, wider, and we will repeat. So let's say the first option. Deeper. With the same quantity. But as you remember, the efficiency does not change with deeper piles. If you have deeper pile, the efficiency will remain same because the formula, look at the formula, has no L parameter. Okay? So the efficiency will remain same. The base reaction will remain same. But I will input everything in here so that I will use for the other design options. Let's start by QB plus 9 times 50 times the diameter. So that we will play with the diameter as well to see. Let's put that as diameter, sorry, that. Times pi, open, close bracket, times base times d squared times divide by 4. Okay? Diameter, let's say 0.4. We kept that same, and this is kilonewton unit. I need your Excels to be presentable. I mean, you need to have name, you need to have value, you need to have another column as unit. Clear. This is what you do in the real life. Unit, value, title. And if you want, you can put reference. For example, in the reference section, you might give definition. Right? For example, single pile base reaction. Okay? We calculated this. Now I can change the diameter if I want. Let's move on to QS. It's 100% clay in this example. So I'm going to use 0.84, that's a constant value, times 50 was assigned to me for the soil. If in your case you will assign different cell so that you will input that CU in there, times pi open close bracket times the diameter times the length. Well, I'm going to change the length. That's why I will put L here. For time being, it was 12. And I calculated that as well. Is it okay so far? Single pile shaft resistance. Let's proceed. Save total single pile resistance. Factor of safety was assigned as 2.5 for the total. So open bracket, this plus that divided by 2.5. And this is, find it here. From there, put it here, and put here, save. Okay, now efficiency. For efficiency, I require M, and I do this once. Okay, preparing Excel is only once, but for optimum design, changing those cells inside, the values in those cells is easy after you prepare the Excel. M and diameter is given and the spacing. Between. From center to center. For time being, what is the spacing? 1.2 meters. And M3, M4 spacing, and we have theta. Theta, you might calculate it on your calculator, or if you want, you can use some functions in Excel to calculate it automatically. But let's say we keep the diameter, but we will change it. Let's see if this is the property. Open bracket, diameter divided by B34. And conversion from radians, this is in radians. Conversion from radians to degrees times 180 divided by 2 divided by 4. I need to check this function. This is the only parameter that we couldn't do it in Excel. 4 divided by. Let me check with my calculator. And You have calculator with you? No? I mean yours. Yes, I found it. The function that you need to use for theta is 18 value that you will input, which is d over s. For Excel, because it calculates it in radians, you need to multiply with 180 and then divide by pi. 3.1415. This is pi. Okay? Now we know the theta. Anything else? No, just efficiency. Let's see. Almost done. So let's see. 1 minus degree times open bracket. This is the general bracket. And then open another bracket for the top row. And then open another bracket. Then it will be 4 minus 1 close bracket times row plus open bracket this minus 1 times that close bracket divide 90 times this times that. I simply input everything that I have in the efficiency and then close the bracket. This is your efficiency value. 0.71 approximately. Then efficient single pile plus this times we initially calculated total safe and the property is kilonewton and total pile group plus this times quantity, right? How many piles? And quantity is 4 times 3. So this times that. Kilonewton. Okay? The same value we initially did. But now I have, look, I have a system here where I can change the values. So let's say I'm going to change the length to 15. Now let's see if 15 is adequate. Not enough. 20. 25. Right. So now I go backwards. Let's say 27 meters with those efficiency values are okay. How do I understand that this design is economic or not? What do you pay for when you construct piles? Concrete. How do I calculate the concrete here? By height, right? You know the total quantity, how many piles, you know the diameter, and you know the total depth. So you can calculate the volume of concrete. It's also important for excavation, right? Because you pay per meter of excavation of piles. This is one option, okay? I'm still not sure, but let's calculate the concrete here. Concrete and excavation volume as the parameter, so that I will use that property to understand if my piles are efficient. I mean, if my design is optimal. So plus this times that is the quantity times depth times area. Did I use the area? No, I didn't use the area. So this times pi, open, close, divide by 4. Is this correct value? 2 tane 0.4. Bir şey var mı burada? Quantity, depth, area. Okay? 41 meter cube. Now I'm going to copy this. Instead, less pile option, not closely attached. Now, a single pile doesn't change so far, but I will keep the minimum first, where we started, the length. And now I'm going to have, let's visit our plan, and remember, which one is to eliminate here? What shall we eliminate? Let's make, and because we need to keep the spacing equal based on this method, I cannot just delete this and not delete those.
You made from the building.
And this is not the only pattern, by the way. You don't have to construct your paths like that. You can also do this. I mean, delete that and that.
Yes.
So the spacing is equal in all sides. Let's say we do this method. Let's say if we have 2 meters in between, what is the total length? And we can extend it by 3.6. And this is 2.4. If I make it 2.4, distance, I will have a greater Let's say I extended my raft, so I put This is the other option. 2.4 meters apart from each other. And this is 2.4. 2.4. Let's see this. It's small plan. Okay, this is not a building plan. Imagine 4 by 2.4 is not a building. But let's try these values. The idea is 5,000 kilonewton again. How many rows? How many? 3. What is the spacing in between? 2.4. Look at my efficiency. From 0.71, it increased to 0.88. However, the quantity of piles are less. Let's proceed. Efficiency single pile, but don't compare with this because this is very deep value. Total capacity became 1,000 this much. So I should increase the depth. Let's do it. 20, 40, 44. Right? Look at the meter cube. So which one is optimal?
This is economical, but I think this one is optimal.
Why? What causes optimum? What is optimum?
Safe.
Is it not safe?
Both are safe.
Both are safe. This is the first condition we check. Right? Look, this and that is above 5,000. If you want, ask. Safe 5,000 less than you calculated. True. The same thing. Which one is more economic? This. So which one is optimum design? This one. Plus that, divide that. It's about 19% more economic. Excavation, steel. Foundation, I mean, we have other parameters, but this is a general understanding for you. I mean, this is the general idea that I want to show you. But of course, having depth for this is 41 meters is deep. You might not be able to find that deep excavation, right?
Yes.
But this is just an idea. Imagine if you have big building, not 5,000, but maybe 100,000 kilometers. The area is too big. Your soil has several layers. So you will decide, maybe this layer of soil is very big, so I will pass that for all combinations. And you can copy paste this as much as you want. Okay? All right. So I will assign your assignment on Moodle and Teams. We will design a building's foundation. Each student will have a different soil. And you will decide the foundation dimension. You will have some constraints, like the area, minimum area, to start with. And then I want a good Excel from you to prepare references, values, and so on. Okay?
Yes.
All right. So.
Can you upload this text into Moodle?
No. If I give this, you just input values.
Just very.
What?
We will just.
Don't push the limit.